Good afternoon, everybody. Kia koto. Simon McManus is my name. I'm the Executive Officer for ITS New Zealand, and welcome to our latest TTEC Reboot event. We're rebooting today the presentations that were to fall under the papers and presentation section of the conference. And so these are all presentations that were submitted and judged and approved for entry into the conference, if you like. So a lot of work has gone into this on behalf of our speakers, and we're really looking forward to getting into it today. A little bit about ITS New Zealand. For those of you who may not know, I'll make this really brief because hopefully you do know who we are. ITS New Zealand is a peak body for intelligent transport systems and future transport solutions in New Zealand. We've been around for quite a while. We kind of link government, industry, academia, and we're also supporting the Young Transport Professionals organisation at the moment as well. So they are the kind of up-and-coming people in our sector. We're really supporting solutions which make transport more sustainable, safe and efficient for New Zealand, and we're connected to a global network of ITS organisations. You can see a little logo there on the screen there for ITS Asia Pacific. So we're a member of ITS Asia Pacific, but there's many ITS organisations globally as well. So we're linked into that too. TTEC is our major annual conference. That was to take place in June this year, cancelled when we had that little tiny COVID scare in Wellington that everybody's well forgotten about by now except us. It was a memorable event. We were about 45 minutes in before we had to evacuate Te Papa at the time. Had Minister Michael Woods walking onto the stage just at that very moment. So that was interesting. So we're a member-based organisation. So you can see the new slide there is just giving you a flavour of who our gold and silver members are. We've got research and education members is a new category we've added in the last year. And beyond these awesome organisations, there's another 40 or so bronze individual members which you can find on our website as well. So it's through the support of these organisations that we're able to hold events like this, and we really value their support and hope that you find all these events really valuable, keeping the conversation going about what's new and how we should be doing things better. So we've got a few more upcoming events. Hopefully you've heard about the very first one there. We're rebooting the second papers and presentation section. These ones are more focused on safety and equity versus today's ones which are on sustainability, or most closely tied to sustainability. Some of them will have a crossover into the others. We then have on November 24th, that's next Wednesday, our annual general meeting, where we do have guest speaker Michael Wood, Minister for Transport, joining us to talk about or give us an update on the government's focus on transport, some of their major milestones and project progression, and what they're thinking, and hopefully also announcing the Waka Kotahi Innovation Fund, which I can't give you too many details on because the Minister will be telling you all about that next week. We look forward to hearing more about it. So cracking on to today, please excuse the advertorial there. Cracking on to today, today's speakers, we've got 7 speakers joining us today, starting off with Erik Zydervelt, who's the founder of Mevo, Luke Fitzpatrick, who's an engineer at Beca, Matt Ensor's a business director at Beca, Peter Carr from EROAD, Chang from Waka Kotahi, Frederick from Beam, and finally Danny Fitzgerald from Fulton Hogan. So as you'll see, we have quite a broad kind of scope here, from mobility to engineering. There's AI in there, there's digitalisation, there's all sorts. So it's going to be a really interesting afternoon, and I hope you enjoy the ride, excuse the pun. So this is the order that we'll be going in today. We'll be starting off with Erik and moving through the list as I gave them to you there. We'll have Q&A after each one of our speakers, just to keep it tight. We'll have a couple of questions each, so that we kind of stay within the time boundaries we've set. So if you can ask your questions through the Q&A function in Zoom, and if you can possibly give context, i.e. where you're coming from, your organisation. That will help the speakers to answer most efficiently. If you can also help us, we have a number of speakers today, so do please state who your question is for, and that will help me as I feed those through to the speakers. We'll collate the questions at the end, so if we do miss your question, we'll be able to pass that on to the speakers, and hopefully they'll be able to get back to you shortly. Yeah, very finally, just be concise and try and keep it to one question per question, so that we're getting through them relatively quickly. That'll be good for everybody. Okie doke. Hopefully that all makes sense. If you've got any questions, please do send them to me in the chat function. So the chat function is there in Zoom, where you can communicate with us. The Q&A is where we'd like you to put the questions, please. Let's crack on. So first of all, Erik Zydervelt is the founder of Mevo Carshare. I'm sure most of you are very familiar with Mevo, and I look forward to hearing what Erik is going to be talking about today in relation to government fleets.
Cool. Kia ora, everyone. I'll just I'll share my screen quickly. Okay, it's saying I can't share my screen.
Okay.
Can I share my screen with you, Simon? If I just send you the link quickly. It's just Google Slides.
You should be able to try that now. Can you try sharing your screen again there, Rick?
There we go. Awesome. Can everyone see that okay?
Yes, I certainly can.
Okay, cool. Well, we'll crack into it. Well, absolute pleasure to be sharing the afternoon with everyone on the call. And for those of you who haven't heard of Mevo, we're Australasia's first free-floating car share, and we are operating in Wellington and Hamilton, soon to be launching in Auckland and other centres around the country before growing internationally. So a little bit about Mevo before we crack into it. We're on a mission to help build more beautiful and livable cities by providing a better alternative to private car ownership. And I guess tucking into the government fleet as an example, but this example certainly plays out into both other private sector fleets around the country, as well as private car ownership. And so we've got this little group of people who are incredibly driven and incredibly bright, working on this really wicked problem, which is private car ownership and the fact that it's just ruining cities around the world. And they're just parked up solving these massive challenging problems, delivering a future that we think is kind of inevitable. You know, we think the age of private car ownership is coming to an end. And so we'll talk into a little bit about why we think such a thing. But I think before we even do that, it's looking at the problems that we're trying to solve, and why we're spending the time and energy, and why thousands of people are following us down this path. So we like exceptionalism in New Zealand, like many other countries, and unfortunately, this is one that we're a leader in the bad way. So 802 cars per 1,000 people in 2018. So it puts us, from memory, it's the 4th largest car ownership rate in the world. Just 21% of our emissions across the country come from transport, as many of us will know, and just on road, let alone the embodied emissions, which we've taken into account in this presentation, but just on road, 4.6 metric tons of carbon emissions per car per year. So a pretty key area for us to meet the ambitious but good targets we've set as a country when it comes to climate change. Again, just crazy numbers of vehicles on the road. Nelson Tasman has more cars than population. So there's 1.01 car for every person in Nelson, which is a bit crazy. So when we look at it, the base cases, as most people on this call will be aware of, is they're just poorly utilized assets. That's really what it comes down to. In the private home, they're the 2nd largest purchase after someone's house, and yet they're only in use 4% of the time. And so one of the key things that Mevo does is stack a lot more of those 4%, that actual value, into individual units. So we have, our cars run at about 40% utilization compared to 4% for the average car. And fleet cars, well, better than private cars. When we tuck into the data of our customers before they sell their fleet and use us instead, they're still pretty terrible. So when we look at this, not only is it a big asset class, but it's not really an asset when you look at the depreciation rate. It just drops off, and that's one of the crazy things, is that cost of depreciation is spread over, it's replicated across so many individual units compared to compiling all of that value into as few units as possible. And recently, as we'll all probably again be aware, the New Zealand government set a target for converting our fleet, and particularly the government fleet, from internal combustion engines into battery electric vehicles, which is great. We're wildly supportive of this. The one thing we'd say is right now it's really fallen short, because a 1-for-1 conversion still gives us just this, it doesn't actually solve the problem of private vehicles. It reduces on-road emissions, but the embodied emissions of replacing the vehicles 1-for-1 is still huge. As an example, a battery electric vehicle, just to build it before it gets on the road, is about 15 tons of embodied emissions. So we think a lot more can be done, and we think, actually, supported by technology and really smart business approach, we can move the government fleet and the larger fleets of our private sector into a shared economy. When we tucked into the government fleet over 3 years, we looked at the status quo of emissions. So, a pretty significant nearly 270,000 tons of emissions under the traditional case study. Then when we look at a 1-for-1 battery electric vehicle replacement, so what's currently planned, there is a good savings, but when you take the embodied emissions as well of the vehicles, that delivers about a 43% reduction in emissions. Now, what we took was not a wild, every car should be shared approach, which we think in time should be the case. But if we say, look, change takes time, and we're saying, actually, you should reduce your total fleet by 30%, and then the use that you need on top of that 70% of your converted fleet, so converting from internal combustion through to battery electric, then the excess requirements are made up by a shared fleet. So that can be shared by the public, all across government and the private sector. Actually, that gives you this huge savings. So it's 72% reduction in emissions. How we achieve this is what we do day to day, and we have thousands and thousands of members using our service as we speak. App-based access to a number or a network of vehicles across multiple cities, and largely on demand. So you need a car, there's one within about 3 minutes walk. We can deliver digital service level agreements to make sure there's always cars within walking distance of any given location. Use and pay for the vehicle as you need it, and drop it off wherever you need to within a kind of defined area around the city. And leave it for the next user. And that means being able to pick up at the airport and drive into the city. So gives you taxi replacement, being able to say, we see people in Wellington, grab cars and drive up to Palmerston North for the day, bring them back. That's another case. And this means that, that ad hoc peak usage of the vehicles can be spread across multiple firms and multiple stakeholders in the community. Now we get to see if my video is going to work for us. So it has to be simple, it has to be easy, and it has to be quick. We have people who currently have fleet vehicles who have to go up flights of stairs to get a logbook and then down to the basement to grab the fleet vehicle. And it's actually quicker for them to use our network of vehicles spread across Wellington and Hamilton. And that's it. So the phone becomes your key to access this network of vehicles. There we go, another one. Now, some of the flow-on effects of moving from, a completely analog, we see a lot of Outlook calendars when we go and talk to customers, or even private fleets that are digital, and there's some great new booking products coming onto the market, is you start to get this network effect. So this is a screenshot of our operating back office to just give you a feel for some of the smarts that are running. So the blue pins are all of our vehicles that are available. You can see that orange circle in the middle. That's an example of a SLA, service level agreement, we're running for a client. So that has a vehicle within walking distance, but it hasn't met our target amount of vehicles available. So we target more than the vehicle you can see in there. And so one of our operations team can go drop off a vehicle to make sure there's enough supply close to that client. And then the little hexagon tiles you can see running, those are actually a platform that allows us to run predictive analytics. So how likely is a vehicle to be needed on our platform in the next hour? And therefore, where should those vehicles be located? And that helps our operations team balance our network. And then all those orange vehicles are vehicles that are out on trips when the screenshot was taken. So that type of smarts allows us to go from that 4% utilization, even if your fleet's used 10% or 15% of the time, which is a fairly well-performing fleet by comparison. This sort of smarts allows us to deliver kind of 40% utilization across our network. And then those savings, of course, come through to the end user. So, I mean, obviously, as this conference testifies, we've had a pretty bumpy last 12 months, but you can see pre-COVID, the number of trips that were being taken on the network just absolutely was going for it, ramping up. And through the lockdowns, where obviously our job's to move people, and the lockdowns are really good at stopping people from moving around, as they should. But we've been able to, first lockdown gave us a huge hit in number of trips. We've been able to grow steadily despite continued lockdowns. And we're expecting this kind of exponential growth in trips to ramp back up as we get back to this new normal that we're coming into, particularly supported by the addition of Hamilton to our network and the very soon addition to Auckland. So one of the key things that underlies all of this is for every vehicle we put down, sorry, this is the wrong slide for the point I'm trying to make, but it's an important one, and I know we're running out of time. A recent Wellington City Council survey found that more than 11 vehicles were taken off the network for every single shared vehicle there was. So that's people who either chose to sell their cars or chose to forego purchasing. So it's greater than order of magnitude reduction in the total number of vehicles to meet the same demand. On top of that, in terms of positive sustainability outcomes, all of our vehicles are run on a climate positive platform, which technically is carbon negative. So there's a net negative impact through our business model. And then users of Carshare are more backed by a study in UC Berkeley to use active and public transport. So we have the numbers to break down this case study that we've put together against a single 100 vehicle fleet, a kind of fictitious fleet, which we could go through and run through the full number of fleet cars, the taxi and rental travel, and how many kilometers, and then running into the carbon impacts that gave us these numbers that I shared earlier. And you can see here the approach we've taken. So if you look at holistic emissions, so both fleet, taxi, and rental car, and then reducing the fleet and moving the vast majority into shared EVs allows us to deliver that 73% reduction in emissions. And we won't spend too much time on these. I just wanted to share that we have them, and happy to share all of this information, but just huge reductions across the board. We'll jump through because I know we're running out of time. But thank you all so much. If you just search Google Mevo white paper, you'll come up with a full white paper we've written on how the government fleet can use new technology to drive EV adoption. And really happy to jump into some questions now as well. Now, Simon, did you want me to read out questions, or did you want to jump on questions and I can respond to you?
Well, if you've got access to the questions there, if you're happy to do so, why don't you go ahead and answer those questions which maybe are common or that you find most interesting to delve into. Bearing in mind, we've just got a few minutes to do so.
Yeah, gotcha. Okay, cool. Well, from Stephen first, what cities will we be extending our fleet into next? So obviously we've talked about Auckland for a long time, and there's a couple of wee cheeky things that have come up on the global stage that slowed that down for us, but Auckland is still very much in the sights, and we're looking forward to announcing that soon. And then we've just been working on a nationwide rollout strategy. So very keen to work with any organization across the country, particularly looking at the bigger population centers. So we've got the top 20 in our sites, plus Queenstown. Any organization with kind of 20 vehicles or more that they'd like to look at helping to launch a car share, we're keen to work with you. And then obviously the users of that would have access to the whole network of Mevo. Let's see, Mahmoud, good to hear from you. Cost emissions trade-off between higher price of battery electric vehicles and more hybrids with higher availability. Look, broadly speaking, once you get a battery electric vehicle running, and we're really excited to be announcing our first fully battery electric vehicle coming onto our fleet in the very near future, particularly the higher utilization that we're seeing on our fleet compared to private ownership or private fleets, battery electric head and shoulders on a full life cycle assessment. That being said, even a low emissions petrol vehicle run on a shared network, if you take the impact as highly positive, particularly when you then measure and offset more than 100% of the emissions, and that helps drive of affordability and equity, as well as, you have to charge more for battery electric. Martin, can we briefly comment on the 15 ton of embedded carbon per BEV? Put simply, they weigh a lot more, and there's a lot more embedded carbon in producing that vehicle. The total life cycle impact of battery electric vehicle running compared to a petrol vehicle is lower, but the upfront built emissions is higher. Okay.
Coach.
Is that all we have time for?
If you can see a really quick one to go with there, Eric. Otherwise, we might just have to wrap it up there. And as I say, I'll pass on these questions to our panelists.
Yeah, I'll jump on a question from Olivia. So are non-government organizations able to sign up to use Mevo? Yeah, we have companies and non-government organizations, community, private sector, signing up every day. So if you just go to mevo.co.nz and find the business tab, you'll be able to fill out a form. We pull all your information in, and then you can bulk upload all your users. So yeah, we work with lots of organizations.
Great.
Cool. Hey, thanks so much.
Thank you very much, Eric. And for those of you who asked questions, we didn't get to them today, apologies. We are under a time limit. Eric's email address is there. I'm sure he'd appreciate any approaches. And as I said, we'll pass on those questions to him. Thank you very much, Eric. I really appreciate it. It's a really exciting area, and obviously decarbonisation is huge on the government agenda at the moment. So hopefully they're listening, and it'll be good to see some more progress. And best of luck for your expansion.
Hey, thanks so much, everyone, for having me. Great to see you.
Thanks. Okay, so next up we have Luke Fitzpatrick. Luke is an engineer at Beca, but he's talking to us today in regards to AI. Luke, do you want to share your screen, and then you can manage the slides from your end?
Yep, all good. If you could please let me know if you guys can see that.
I can now. That's great. Yep.
Cool. Thanks, Simon. Hi, everyone. I'm Luke, and I'll be talking about a project that I've run with Beca about improving community equity with AI. I'm going to be a little bit more selfish than Eric was and start with talking about myself than about my company. So I've been lucky enough to work at Beca as a transport engineer and an artificial intelligence researcher, which sounds pretty fancy, but when I started, I actually had no idea what it was. But what I did know was that I would have the opportunity to help people and communities, and that I could especially give back to Pacific communities, which was really cool for me to do in the industry. During my time at Beca, together within a really good and diverse team of people, we were able to create Tala and other conversational agents. That's me on the end, the one in the photo that doesn't smile. The project we worked on was called the Talanoa Project. Talanoa is a Samoan word for conversation or discussion, and that's the main idea of what we wanted to create with the Samoan Consultation Project. Consultancy in communities is really good for governments or councils to see how community members feel about certain projects like buildings, roadworks, even schools. And we wanted to try to get feedback on the potential use of a Samoan speaking consultation agent named Tala. Our team at Beca were basically running a pilot test to see if this was possible and test with the community members to check if it was indeed beneficial as we envisioned. The Samoan community in New Zealand is actually pretty big, and it's the third most spoken language in New Zealand and the highest non-national language. Our Talanoa project aimed to help get the opinions and engagement from these people in the community who usually wouldn't voice their opinions, because though these opinions aren't shared, they're still very valuable for us in order to provide for different needs of communities. What we found was that AI needs to be trained not only to understand someone, but also to understand the culture and the way things should be done when working with Samoan communities and with Samoan speakers. With the creation of the Talanoa agent, we had a few known barriers and challenges that we had to think about. The actual translation was the first barrier. As most of you probably know, translation services are pretty inconsistent, and besides incorrect translations, we also had the problem that translating in one direction might give a different result than translating in another direction. Example of that would be the word yes in English. If we put that into Google Translate, it translates into Samoan as ioi, I-O-E, which is correct. If we reverse the direction, then it translates back to English as I do, which is different and is something we had to make sure of to ensure that our outputs that we're giving were always correct. Translating conversations required a lot more knowledge than I have myself, and so I got help from community members and my family who are experts in Samoan language and culture to get these Samoan translations. What we found was that for a translation service to work efficiently and a language to be used appropriately, our input is best translated and best understood when it's simplified and in a common sentence structure. So this included changing things like public transport to instead buses and trains and other services, and urban development instead to building in the city, and some other simplifications like that. Something else that was also considered in every response was that in Samoan, there are two different ways of saying things, not exactly two different dialects, but a formal and informal way. Along with the language used, some phrases also had to be changed. For example, in this consultation agent, we wouldn't ask questions specifically to get opinions against government projects because it's not very appropriate as culturally it's not good or traditional to go against authority, but instead maintain respect. And this relates back to our understanding of culture and something that we needed to get right, to have a good balance of each so that the language we use is comfortable but respectful and familiar within our target audience. We tried to have the greatest understanding of culture and language so that our engagement felt real and authentic. After this development, someone speaking agent was made, and we tested this agent within Samoan communities with members aged from 19 to 70 in New Zealand, Samoa, and Australia. This was to get a broad spectrum of the languages that were being used by different generations and also throughout different areas where Samoan is often spoken. We wanted to trial to test whether the real-time translation capability was possible for people that replied in Samoan. And we wanted to see the tendencies and nuances that people use with the language. For example, spelling words as they are spoken or as they are written, and understanding modern slang. Overall, we wish to see whether our talanoa or our conversation could run smoothly. After some training and testing in both English and Samoan, the conversation looked something like this. And we had a conversational agent that could message you questions in Samoan, and you could reply in English or Samoan, whatever you feel comfortable with. And as you can see, the conversation ran quite smoothly, proving that the real-time translation was working correctly and understanding what was needed to be understood. I know a lot of you won't be able to understand most of what is going on the screen at the moment, but you can take my word for it that it works. And I'm not just saying that because you guys can't understand it. But this conversation was a starting point where we could then use on multiple platforms such as websites or person on Facebook Messenger for people to speak to. After the conversation, we could end up with a dashboard of information that looks something like this, where topics most spoken about can easily be seen, as well as what comments were made about different aspects in the conversation, and also all in English. After the testing, it was important for us to get feedback from all our users to understand what went well and what didn't and what could be improved. Not only to help us train our AI, but also to see how technology could be used and if it's new and unique. We interviewed users before they used our agent to give us valuable insights into how people generally feel about this kind of technology. In summary, many people found that chatbots or conversational agents in general are new to Samoan communities, and because of that, people felt uncomfortable interacting with them. And further from that, because of that, they were worried about their privacy and wouldn't share true opinions through it. And lastly, technology could be difficult to access for different parts of certain communities. After we found that feedback, we were able to try our Talanoa agent with our audience and then interview them further after they used it. But this time, instead asking about our conversational agent instead of chatbots in general. What we found was people felt much more comfortable and relatable to having a conversation, especially if it's in their own language. And this meant that for most people, they're willing to share more and converse more openly, which is exactly what we wanted. We found that when technology is represented with an understanding of language and culture, it creates a much closer and personal connection, which is perfect for community consultation. From some of the feedback here that we have, positive and negative, we can see that few users relish the opportunity to be able to speak and converse openly in their mother tongue, which was especially evident with our elders in our community who prefer to only speak in Samoan. But also because technology is advancing and is new to communities, the comfortability that was provided by the language sometimes didn't fully outweigh the discomforts people have with technology. Though we believe that with technology becoming normal in everyday life, this stance is likely to change, if not already. Overall, with the feedback given, this is the first of its kind and could serve as a great platform to pass cultural and community information. In conclusion, our pilot was successful in proving the ability of real-time translation. We could see that it has great potential for use as a community engagement tool for presenting or retrieving information. And with our aim of having the widest community engagement possible, similar methodologies could be adopted to have more languages and to reach more parts of the community, not just Samoan, which we have begun at the moment with adding Maori and Mandarin. The most important factor is that the culture and the language must be well understood, and that comes with the people working on it behind the scenes, being from that culture and expressing it into technology and AI. Finally, the translation technology could be adapted and applied in multiple different use cases through transport and beyond, ultimately with the end goal of creating a technology that could help all people. That's all I have for today. Thanks everyone, and thanks to ITS New Zealand and TTEC for the opportunity.
Thank you very much, Luke. Sounds like a really awesome experience. Here's my timer, so you're perfectly on time there. You're perfectly on time. That was, a really interesting project. And interesting to hear the feedback from people. Obviously going out of your way to speak to them in their language, but there's still the technology barrier a little bit there. But I guess the value is, if you're reaching a huge number of people that can't necessarily get along to, a community engagement day or something like that. So it's increasing accessibility that way as well. We do have a question for you, Luke. This is from Karatiana. Sorry if I got your name wrong there. She says, Talofa and also Mahi, can you go into the accessibility a bit more? Keen to understand if W3C standards were embedded and localization by region was used in Samoa at all. Does that make sense to you?
With the accessibility, it's sort of known that Pacific communities and other minority communities may have less access to technology or the ability to be online or within New Zealand and also within other countries like Samoa. But our main solution for that was that in New Zealand today and with technology grants and within Samoa also, technology is just adapting and being being accepted by almost all communities around the world as a way forward. And so reaching those communities, we're able to do it in whichever way we feel would be best for them. As I mentioned, some might be just online on the website. Some might be through a different messaging platform like Facebook or something.
Mm-hmm.
Whatever nations or communities feel comfortable with.
We've got, yeah, thanks for that. I've got a second question here for you as well, just to address this one quickly. It's from Joe Chang, one of your other panelists today as well. So thanks for chiming in, Joe. She says it was a really interesting talk and she enjoyed it. Were there any cultural aspects that you learnt could also benefit consultation in general? So I guess learning in reverse, what the feedback may be useful for other consultation, I guess is what she's getting at.
Yep. So a lot of it was about kind of understanding our audience and how people would like to be spoken to within different areas, and that changes with not just with culture but with generations and how people are brought up, which is something that should be always thought of when going out with consultation. Also with the language that is being used, it needs to not be kind of intimidating, but more easy for anyone to understand, and more of a listening tool than trying to ask and get information from people, but creating an environment where people are more open to speak and comfortable to speak, which would help with your consultation on whatever topic if people are speaking what they actually want to speak.
Yeah, it's pretty good insights. Thank you very much for sharing that, Luke. Really appreciated it, and hopefully you stick around and enjoy the rest of the presentations as well. Thank you very much.
Thank you.
So next we have Matthew Ensor, who's Business Director Advisor at Beca. And Matt, if you can share your screen. There we go. And remember to unmute yourself and you should be able to engage with our audience.
Right. Kia ora koutou. Welcome everyone. Thank you for staying on. And I'm going to talk about transformation. So this is transformation. This is just from a couple of weeks ago. Flight across Cook Strait, Gary Friedman, cost him $2 in electricity to do that. And there's pretty much no maintenance on the aircraft. So that is pretty much the operating cost. I used to commute to Beca before COVID kind of put something in the works. It used to cost me 3 cents in electricity to get through my 15-kilometre commute. So this is transformational. If we can get people's transport costs down to this kind of level, it should transform the amount of money they have spent on other things. Here's an article just from a week or so ago out of the US, Fast Company. And so the US are going through the Build Back Better Act, which will subsidise electric vehicles even more than previously, but will also subsidise electric bikes, but not in a way that's nearly as generous. And so this article says, well, why is this? Aren't electric bikes far more transformational for the transport network? You know, funnily enough, in New Zealand, there is a subsidy for electric vehicles, but nothing for electric bikes. Despite that, Oliver Bruce, one of my partners in research, has this graph here, which shows that actually the revolution in terms of number of devices sold is in micromobility. It's not in electric vehicles. The question, of course, is, well, if that's the case, where are all these electric bikes? Why aren't we seeing them swamping our streets? And so that's a question I'll answer in my research. What is micromobility? Micromobility basically is battery technology. So it's batteries that are stuck onto transport devices to make them easier to ride, bigger travel distances, higher speeds. One of the things I would say is it's changing very quickly, micromobility. So particularly for people with mobility issues, you know, this here is the old technology. This here is kind of the new technology. And I think what we'll see is an explosion in the amount of micromobility that's used by people who would never use an e-bike or an e-scooter. One of the big issues, and this isn't in my paper, but it's research I did afterwards. It's taking the ITF's graph, which basically puts The length of the thing here, the bar, is the amount of effective carbon equivalent per passenger kilometre over the lifetime of the vehicle. And so we're sitting about here with internal combustion engines, big push to move us to here, which is battery electric vehicles. So you can see pretty cool, saving about half of the carbon emissions. But look at this. This is even cooler. So this is a private e-bike and a private e-scooter. The reason that's so long is that e-scooters tend to have a relatively short life in terms of number of kilometers. Hopefully over time, as technology gets better, that will get shorter. So hey, look at this. Move from here to here, or maybe move from here to here, but it even gets better. I mean, look at this. This is electric powered public transport. So imagine if we can, through micromobility, get more people to get onto public transport. And so the question I wanted to answer in my research was this: actually, is it significant enough that we should look up and change the way we plan and invest in public transport? I had to do a bit of a literature review, good and bad. What we found was that there's quite a lot of information out there around people who are deciding to move to micromobility. And one of the interesting things for me is that the information is relatively uniform all over the world. So the proclivity of people to stop walking and hop onto an e-scooter was much the same in New Zealand, the US, or Europe. But there was this one big gap. And so this is what my research does, is it puts the puzzle piece into that. And that was, there was no independent peer-reviewed research that forecast the growth and mode shift to micromobility. There was nothing. And so that's the gap that my research filled. What we did find as part of the literature review was work by Horace Dediu. And what he found was that for micromobility of different types, there was definitely a profile in terms of what particular trip distances those micromobility were used from. And so this formed the basis of our research. We've used what's called a market approach. So these are all the trips in Auckland. We've broken them down by 500-metre bins in terms of the trip distance. And so you can see, walking trips are mostly short distances, cycling short, but, a bit better than walking. And so what we've done is looked at, if this is the whole market, how do we work out how many of these trips will move to micromobility? Through the research, we came up with 4 things that make a difference. So here they are. Certainly one is the trip range for the mode. So e-scooters, lower trip range than e-bikes. Preferences between micromobility modes. This was around, if you could make a choice, would you hop on an e-scooter or an e-bike? Uptake basically reflects the fact that your 91-year-old mother might not hop onto an e-bike. Well, actually, she may well do at 91 still. But there are a group of people within the community who will never, ever consider micromobility for whatever reason that is. And the final one was, what is the current mode of trip? So it's actually a lot easier to get people to mode shift from public transport or walking than it is to get them out of their car. Our research showed that we couldn't get specific numbers for this. So what we did is we used scenarios. We had a low scenario, a medium scenario, and a high scenario for each of these factors. And to cut a long story short, it led to these graphs here. So let me take you through these. So at the bottom here on the x-axis is the length of the trip. And up here is the amount of the percentage of those trips that would shift to, in this case, e-bikes. So what you can see, this is the low scenarios, medium scenarios, and high scenarios. So if you're really, really, really optimistic and everything goes really well, for some trip lengths, you're going to get up to 20% mode shift. And you can see here, it's relatively flat as it goes out, the percentage of trips that would shift, but the number of trips actually drops off. And you can see the tail actually doesn't quite end for e-bikes at 20 kilometers, even though that's what we've assumed. It will continue on, but those are very low numbers of trips. And you can see from e-scooters, it's peaking about 1 to 1.5 kilometers. So I've literally cut and pasted this out of my research paper. And I've just highlighted some interesting things. So it's a bit of a myth that everyone's going to stop walking and get on e-scooters. In fact, it's about 3% of people, well, at least 3% of people, in a really optimistic scenario, 15% of people will stop walking and get on e-bikes. And it's actually roughly much the same for, for e-scooters, and much the same for e-bikes. This is interesting. The cycling numbers are quite low compared to, the trips numbers are low compared to all the other modes. But our research suggests that about a third to a half of people who are on push bikes will move to e-bikes. And something else that's worth thinking about is that people who are already using public transport, 3 to 10% of them will hop off and ride their e-bikes. So I'll show you what the answers, what we found. These are the headline figures up to, that's the most that you'll get. What we found was that e-scooters typically in somewhere in that range between 1 and 5%. E-scooters mostly in CBD, generally a lot more than 3%. But what we found for e-bikes is that you get much higher rates when you're in suburbs close to CBDs. And this is because it's relatively a large attractor of trips, CBD, and the trip lengths are about right. So that's when you'll get up to 8%. Typically, it will be around 5%. These are the factors that kind of determine where you might be on that range. I just want to talk about a couple. One is, this is number one, so separated safe infrastructure. So getting riders away from cars and pedestrians. There's a lot, I'll talk about this a little bit later on, but that people aren't attracted to the shortest routes, they're attracted to safe routes that have nice scenery, might go past playgrounds, coffee shops and things like that. This last one here is key. What we found, it is a massive barrier for a good proportion of the population to be able to buy an e-bike or an e-scooter. So that $1,000, $2,000, actually they'll never get the benefit of a 3-cent commute. And so there's a big role here to actually heavily subsidize the purchase of micromobility. Not like public transport where you subsidize use, here you've got to subsidize purchase. We also looked at, if you have micromobility, what will people could use it to ride to public transport or ride from public transport to the destination. Here's your headline, up to 9% increase in public transport trips. But what you can see is it's somewhere between 3 and 9%. It does make a big difference how available micromobility is. So there is a role for shared micromobility in there to get that number up. Typically, the range is about 6%, so you get a 6% increase in public transport. Again, here are the factors. What I would want to say is just have a look at this one here. It does make a difference if you can take it on board. Buses and trains and ferries, it drives me bonkers. They're designed like we're still back in 2000. They're designed to move people. What public transport vehicles should be is intermodal collection devices. So if you happen to be on a scooter, you should be able to ride on into that bus and take it with you onto the ferry, take your e-bikes and those sort of things. What my research does is give us the ability to work out, what buses and ferries should look like into the future. So starting to wind up, we actually used the Ministry of Transport's Wellbeing and Livability framework. So this was to work out, because there are a lot of people saying, oh, it's great, Matt, but actually I don't like micromobility. And they'll tell us the reasons why. So what we did is we did a review, and what we found was inclusive access was a problem. I've talked a little bit about the purchase cost, but there's also, if you live out in this commuting suburbs, the trip distances are just too long for e-bikes and e-scooters. Healthy and safe people, people get hurt and will trip over e-scooters and things like that. And so what we did is we took all this and we came up with 21 interventions. So this, you could call it a best practice guide. What did we learn from around the world that we should do to minimize the negative impacts and maximize the positive impacts? Now, I could go through all 21, not enough time. So here's my highlights. Here's my 5 favorite. Actually find some safe, enjoyable routes and invest. This one here, what we're finding is that it's just an immaturity on part of people who operate the streets and footpaths, is that we're not making enough parking areas. We wouldn't dream of not doing it for cars. For some reason, we haven't quite got around to doing it for scooters. So people are not quite sure where they can leave their scooters. They're not quite sure what to do. They just leave them wherever they are. The other thing is around speeds. Again, people aren't putting up speed limits because they're not regulatory. They can't be prosecuted. What we're saying is that what we're finding is that there's just this lack of social understanding. No one's saying what the standard is for speed, and so everyone's very unnerved by it, and riders are unsure what they can do. I've talked about grant schemes. talked about public transport. So I'm just going to finish with this one, is that when the public transport system has an outage or there's a natural disaster, micromobility has a big role. E-bikes, e-scooters can get around when other modes of transport are entirely stuffed. So to finish, it would be a bit sad if this was the final outcome of my research. Having said that, there'd be lots of people on Talkback who were like, I knew this. So what we are saying is actually 9 out of 10 trips probably will never move to micromobility. There'll have to be massive land use changes and things which are outside of the 2030 forecasts that I've done. But this is the kicker, is that we tend to be investing in separated safe infrastructure using forecasting models for push bikes. And what I'm saying is grab those benefit cost ratios, multiply them by 4, and that's probably about right. And so what that should do is help the business cases phenomenally with this kind of stuff. And it's going to take 5 to 10 years to implement this kind of stuff. And so all I'd say to finish is that we need to start now. This is urgent. We now have the data to forecast. We should get on with it. Thank you.
Excellent, Matt. Thanks very much. I'm converted, but I was already converted. So no, it was great. I need to obviously get a hold of your research paper and take a bit of look myself. I'm going to crack straight on into the questions, and I know you can answer this one from Armin Gutka. When do you forecast micromobility imports to overtake new car imports?
Yeah, that's Oliver Bruce actually. He has a year in mind, and I think it might be next year.
It is next year. Yeah. That's actually total new cars. We're not even talking, EVs. This is total new cars.
So wouldn't it be odd if we weren't changing the way we planned our transport network?
That's right. And we do have another question here from Martin Huang. Are the mode shift research based on New Zealand stats or international?
So that's a great question, Martin. And yeah, there's lots more in the research paper you can see. So it's based on international data, of which the New Zealand data kind of fits in. We were really surprised that the data is really consistent. And so we didn't need to adjust it for New Zealand situations. Even cities like Paris are having similar kind of stats on who's moving. And in fact, Paris is one that I'm looking at very carefully because of all the amazing work they're doing. They're like a test case. I think that last question, Mahmood, is an interesting one. I think we have to be honest with people and say, look, everyone's not going to hop on an e-bike. I think often it's seen as a magic bullet or a silver bullet. What I'd say is that I suppose the e-bikes themselves, and this is Oliver's graph, are really popular. And so there's a big overwhelming support in the public for using e-bikes, but it's just not going to happen unless we actually invest in the infrastructure. So there's all these e-bikes sitting in people's garages or whatever, not being used. So I think we need to focus on those numbers. And as Simon said, there's more new e-bikes per year than new cars. The world's changing.
Excellent. Thank you very much, Matthew Ensor. That was wonderful, and I really appreciated you covered quite a bit of ground there. So thanks very much for sharing. Next, we move on to Peter Carr, who is from EROAD. Just bring up my slide there. So Peter Carr is a director at EROAD, and Peter Carr is talking broadly about digitalisation. And Peter, if you would like to share your screen with us, and you can take the stage.
Thank you very much. I'll just bring that up. Right, can we see that?
I've got it. Yep, that's great. Thank you very much.
Cool. Tēnā koutou katoa, ko Peter Carr taku ingoa. I am the Director, wait for the long bit, Regulatory Market Development for Australia and New Zealand with EROAD, which really means that I spend a lot of time interacting with government. I am a product of government, however, 22 years New Zealand Public Service, including a big stint at the Ministry of Transport, where, among other things, I implemented the policy into the Road User Charges Act reforms from 2012, which is what this little presentation has a quick look at. I guess the theme of this is that digitisation and the labour-saving effects around automation that digitisation supports are good things. I chuck those in quotes because even though they're good things, government in New Zealand at least, but elsewhere in the world, has tended to get itself in trouble when doing really big pushes towards digitisation. It's ultimately delivered everything, but it tends to be a painful, or has tended to be in some cases, a painful and public experience to do so. And one of the things that happens is that means it's very difficult to maintain momentum around system improvements. It's very difficult to get people enthusiastic about making changes, even where the benefits might be at least intuitively obvious. And some of that is that the benefits aren't empirically obvious because actually we haven't really looked at them. So this, if there were a subtext to this presentation, it's that government, have a look at your successes, or even with the failures where they've ultimately started working, and just think about actually the benefits that have been accruing slowly, unglamorously, but inevitably in the background in consequence of those changes. So, the Road User Charges Act was actually reformed in 2012, and it was evaluated after that by me and my team. But one of the questions we never asked was whether the digitisation aspect of it worked in and of itself. And that's important because the evaluation was intended to look at the purpose of the 2012 reforms, which was to simplify the RUC system, to make it administratively more simple, reduce opportunities for evasion, and to fix the cost allocation model so that the road transport industry in particular would feel assured that the costs that were being passed to it were a fair share for the level of work they were placing on the system. So if you're thinking sustainability, this presentation is a little bit more about revenue sustainability than the other aspects of sustainability we've been looking at. Now, EROAD happened, but it wasn't the focus of this. In fact, digitisation of road user charges commenced in around about 2010 with changes in both the then New Zealand Transport Agency, Waka Kotahi, as we think of them today, and the introduction of electronic road user charges. So that was 2 years before the legislative changes. So it was very much a side act. But nonetheless, I argue that it was still in and of itself an important one. So the piece of work I did was to try and estimate what the benefits were at a system level of EROAD specifically. To do that, I basically did 2 case studies, one based on 2008-9, which took the figures, costs and benefit figures developed by the independent review of the road user charges system, and then repeated those in 2018-19. Mostly it was drawing on information from annual reports, estimates, SOIs, where they would give predictive information and so forth, so publicly available information, as well as transactional information from Waka Kotahi that they share with EROAD where I work as a RUC service provider. To ruin the punch, some of the punchline, the biggest cost savings in RUC come from reducing the transaction costs to the user. And the time savings involved in preparing for a transaction, not the actual transaction itself. Now, the independent review estimates an average time cost of 30 minutes per vehicle per transaction. And in making the comparison, we've gone for a very conservative number for an electronic transaction of 5 minutes preparation time. And that is conservative because we've been given information by various customers that have shown that for the bulk of their vehicles, it's actually less than a minute. But the bigger the operation, the more sophisticated they can be, the more that they can create and capture those savings. So essentially the methodology is take a known set of numbers, build a framework for it, which is what the coloured chart here is, and find those same comparative numbers again for the year that I'm looking at, the year that we looked at, 2018-19. In both cases, inflation adjusted the numbers to $2020, so you could just do straight comparisons between the two. The thing with the framework is tax is really black and white. You're either meant to pay or you're not meant to pay, and you either do pay or you don't pay. And that gives you, true false kind of relationships. But a system, of course, is never really that simple. And so what you then have is the costs that we look at are all the bits of architecture needed around that in order to ensure that your true positives are indeed true positives, your true falses are indeed, and to cope with the consequences of false positives and false negatives, be that refunds on one hand or prosecutions on the other. Now, as a model, RUC and EROAD and consequence of it, there are things that have to happen. You have to be able to measure distance, you have to be able to record that reading or take a reading of that measurement and then record that. in your claim, you then file that, and then someone completes it. That can be done mechanically or manually, or it can be done fully automatically, and there are halfway houses at each of those steps, and indeed across the whole. And there's a whole range of various technologies emerging, starting from obviously what was built into the vehicles with their own odometers and using a notepad, which is still actually fairly popular with a reasonable percentage of people. I've put at the top right corner the kind of aftermarket device that EROAD has come up with, but the reality is that that's going away with the technology in new trucks and cars. The capability to create the information needed is just going to be supplied. And with all of the EV type solutions discussed already today, they're just naturally generating that kind of information in the background. So that aftermarket equipment will disappear at some point, along with the older vehicles that need it. So with two scenarios, 2008-09 is basically, there's a little bit of electronic assistance in that system, but it's incredibly primitive. It's largely a manual system. Now these slides in the full paper will be available, so I won't dwell too much on describing these. You'll be able to have a look at those later. You get to the 18-19 system, and between the changes at Waka Kotahi and through EROAD and the other electronic service providers for RUC, you've now got these fully automated pathways, as well as a reasonable uptake of semi-automated pathways going through. So it's possible to do a RUC transaction end-to-end with a couple of keystrokes. So what does that all mean? Well, this table just brings the basics together. It's the numbers from the two scenarios against the framework outline converted into 2020 dollars. I think for the purposes of the next few slides, it's just worth having a look at the changes here, which is that in 2008-2009, you're looking at 620,000 vehicles paying RUC, generating about 2 million purchase transactions per annum. By 2018-19, you're looking at 912,000 vehicles that are liable to pay RUC, generating just under 3.4 million purchase transactions per year. So quite significant growth, 47% growth in target population, 70% growth in activity, which is what you see here, 47% fleet growth, matching that 64% increase in revenue over that same period. But a decrease in revenue per transaction. So if you look at it just on the surface, it's got slightly less efficient, less revenue per transaction. Shifting in the background there, you can see in the first year I have numbers for 2009-10, EROAD acquired 1% of market share. Internet sales directly through the NZTA were also at 1%. By the time we get to 2014-15, just after the evaluations, EROAD is dealing with a quarter of transactions. The internet channel has only grown to 10%. And then in the next 5 years, you see the internet channel is growing quite quickly, but EROAD continues to push up. And the two areas you see being consumed by these growth in internet sales, on the one hand, and internet via EROAD, are something called Direct Connect, which industry could do, where it's basically self-serve by having a direct connection through to Waka Kotahi, and the counter agent. So that's physically turning up with your Odo reading written on your notepad with your cash in hand, filling out your form, buying a license and walking off. So definitely a big shift towards more digital options. Benefits though, so what you see in terms of public sector cost of RUC is the total cost of administering RUC rose 8% in real terms, with the total cost to collect as a percentage of revenue, not a share, properly speaking, it fell 34% from 4.5% of revenue to 3%. The cost per transaction fell 36%, and the cost to government per transaction fell 42% from $11.05 to $6.45. So this is total costs. It's not just the admin fee, it's the cost of the system in the background, cost of preparation time, and so forth. In terms of the impact on private costs, noting that the revenue per transaction went down, what we see is the payer direct share of the total cost of administering RUC rose from 53% to 57%, and the average number of transactions per vehicle increased from 3.2 to 3.7. Now, one thing to remember is that the government side of cost is actually collected via an admin fee from the user, plus some voted funds passed in. So any savings on the government side at the end of the day becomes savings on the private side as well. These are things that the road user doesn't have to meet through their admin fee components. Something else that's very true today, not so much right at the beginning, is that EROAD tends to be delivered at cost these days. The cost for Iraq in and of itself has tended to move in nominal terms in only one direction, thanks to competition, which is sideways and slightly down. So if you're a supplier of Iraq services, you tend to make your profit from the other services that you're able to deliver someone. And in fact, more and more, in the first 5 years, the people who picked up Iraq tended to have a lot of off-roads and complicated off-roads. And so they bought Iraq because they wanted Iraq. You know, it literally saved them thousands of hours and earned them millions of dollars in overpaid taxes recovered. After that, though, people tend to buy these systems for some other reason, and then Iraq is just something they bang on because actually they have some RUC vehicles and it makes it easier. So Iraq is delivered at cost for supplier profits from other services, user benefits from the total package. But what we've seen with the increase in transactions, Iraq users have reinvested some of their savings into smoothing cash flows. And that seems to be quite a big driver. To see that, you look at a counterfactual. What if Iraq hadn't happened? Well, one of the things that would have happened is there'd be 450,000 fewer transactions per year compared to the case study, because the cost to serve of a customer would remain the same. There are savings on the government side, but they don't reduce the work needed on the private side in the absence of something else happening. But the cost per transaction decreases only 43% in consequence of that. So actually, if you remember, there were 1.398 million more transactions. So a 450,000 reduction in that still leaves 900,000 new transactions in the system, but only a 43% reduction in the cost. So the total cost of RUC today, if you did not have eRUC, lowering the cost on the user side, would be 13% higher than it is today at 6.6 million per annum. So what we can see there is an invisible benefit, fundamentally. It's money that people ended up not spending. And they'd have to imagine a different future that, for the purposes of counterfactuals, is only allowed to be one step different. And that's not how we tend to imagine the future. We tend to imagine lots of things being different. But nonetheless, we can see in this that actually there's a meaningful reduction in the real cost. And that got translated into people buying more often to smooth their cash flows. To speak to the topics for the conference, has this really helped sustainability? It probably has for revenue sustainability. I still walk into rooms and there's one gentleman who points and he says, he's from EROAD, we hate them, they saved RUC. It's like, well, we didn't save RUC. Governments on both sides of the house wanted to save it, but we became the face of saving RUC, and it hurt us in the South Island for a long time, actually, but we're now past that. It did make RUC a lot easier for people. In relation to environmental goals, we can't claim that. We know that people who put our systems in their vehicles can see a lot more of what they do, and there's a lazy 4% in fuel savings sitting out there that most of our customers have grabbed. And we've also had customers grab double-figure savings in fuel because they've realised they've had too many vehicles in their fleet. So, you know, similar to a story earlier that we heard earlier tonight. But that's very hard to measure because that kind of information is actually quite sensitive to our customers, because if their customers find out they're saving money, then they'll be pushing for lower prices again. And one thing New Zealand does have is an oversupply of transport operators and a bit of a race to the bottom happening around about the bottom 20% of the fleet, where people are just consistently undercutting each other. So those people who are able to maintain a premium guard that, and they guard it very energetically. So at best, we can hypothesize that the data and insights from eRUC systems are making things less worse on the environmental sustainability side of things. On safety, have the eRUC services improved road safety? No. Have the systems we've provided helped? Probably. Technology is not magic. At the time we did this case study with 38,000 heavy vehicles using our systems, we could see an actual 47% reduction in overspeed events. If you look at Road to Zero, there's a volumetric relationship used to understand the presence of speed in the system and the propensity to harm. If you follow those volumetric kind of assumptions, you could say that there were 1 to 2 fewer fatality causing crashes, 2 to 4 fewer serious injury causing crashes, 5 to 16 fewer other injury causing crashes. So between an $8 to $13 million reduction in the social cost. But it's only from less than 1% of New Zealand fleet, so completely washed out by everything else that's been going on around it. But we actually feel quite confident about those numbers to the extent that we've got reasonable benchmarks we can leverage. And we're more than open to have government partners come along and work with us to do more substantive evaluation of that. Has it improved equity? Nope, it's not our concern. Has it made it less equitable? Nope, but again, also not our concern. I mean, the reality is that we deal with people who have the level of maturity where they want this information. It typically means they're not caught down in that bottom 20% eating itself for stray jobs. they're operating somewhere else, top 50% easily. So these are viable businesses that want to think that way. Operators who are down in that bottom 20%, not all of them by any shake of the stick, but many, they want to be there. They're using the grey, they're using the dark, and they run their businesses and they keep them afloat by hiding things in those shadows. So the last thing they want is a system like ours that creates unalterable information on what's actually going on. We greatly simplify the investigative process, which is again fantastic for our customers because it saves them a lot of time on data sharing when their audits come up or things go wrong for them. But for the person playing in the grey, who's allowed to play in the grey, they don't want us. And we know that because we've had a few sent in our direction by the regulator, and once they've realised what we do and what they would be obligated to do with the data, since everyone knows we have it on them, they've walked away. So there you go. I suppose you could say we help level the playing field a little. So in conclusion, have EROAD technologies and services been successful? We argue yes. We think there's measurable savings there that can be put on the table. Is there more that can be done? Also yes. The difficulty of change and the fear of change means that basic things, removing paper labels, digitising other forms of documentation that need to be with the vehicle, how with inward-facing cameras, facial recognition and COVID passports, we could also simplify boundary crossing if you wanted to without any living person seeing the private data of the living person driving that truck. You can just in the background through APIs, do these assertions off there that are attached to real documents sitting in the background. You just get a straight board of ticks and the vehicle could be flagged all the way through. That's what's sitting there now. Hundreds, if not thousands of hours of time savings. And that's what we think government needs to be pushing towards. And to the extent that these numbers might build some confidence that doing the little changes that make these things available and integratable is worth doing, then this will be considered successful. So there you go, a little bit of a digression from some of the earlier themes. I hope you found it interesting and thank you for your time.
Thank you very much, Peter. You've run a little bit over time, so we'll actually keep the questions to just one from me. Sorry if you did cover it early on. What percentage of that fleet is now using EROAD in total? Did you say it was 42?
So we have about 46,000 heavy vehicles using our system. Our competitors have about a fifth again on top of that. There are 160,000 heavy vehicles running commercially in New Zealand. So, we are looking now at a very strong third of the heavy vehicle fleet has something of this nature on board. Light vehicles much smaller. We're running about 22,000 connected, and there won't be too many more off the others. So, it's a drop in the bucket compared to the 621,000. But on the heavy side of things, it's a very, very significant percentage. And they are often, they're in the commercial multi-vehicle fleets. Not just transport, it's construction, it's waste.
As you say, you can't share too much because it's private and sensitive to your customers, but there must be some other savings going on in there as well that you haven't covered. You've kind of covered the public-facing stuff. That's excellent. Thank you very much for sharing all of that with us, Peter. Quite a bit of work there, and I'm sure there will be progression in EROAD here in New Zealand, and let's hope it keeps to generating benefits for everybody. Thank you very much.
You're welcome. Thank you.
Okay, we are now moving on to our fifth speaker for today, which is Joe Chang from Waka Kotahi, and Joe is going to be talking about COVID. In relation to transport, I think. Joe, if you're there and you can share your screen, please do so. Bring up your first one there. There we go. Excellent. Got your screen there.
Have you got just the one?
No, we've got the whole thing.
You got the whole thing.
Slideshow up the top.
Slideshow. Trying to find it now.
Right up the top, if you get a slideshow, and then it's generally play. Yep, that one there.
Oops, that didn't work. Sorry. I feel like it's
That one there, yep. And from the beginning, there you go.
okay. Cool. Kia ora, everyone. Sorry about that. What I want to do with this talk today is I just really wanted to do two things. One is raise awareness of some of the data that we've been collecting through the COVID pandemic. And then two, put out a bit of a challenge to the ITS sector with respect to how can ITS assist with the recovery and response. I had really wanted to just say recovery then and not response, but I think Delta has kind of made that response thing that we're still in it. So I'm just going to skip through to here. So basically, I'm not going to go into too much detail on the project itself, just a little bit on the study design and then a little bit on the results. So effectively, the study, we contracted Ipsos to undertake the research for us. It was an online 15-minute quantitative survey of nationally representative sample. We were doing it weekly at the beginning of when we first went into lockdown. So that was around the 3rd of April 2020, and it's been going on continuously ever since. But we've reduced the frequency that we're doing it now. And it's about, generally it's a sample of about 1,260 adults, including people with disabilities. And the purpose of all of this was, as we kind of went into that first lockdown and we were all scurrying around, we were looking at what do we need to do, what could we do that would help. So one of the things that we thought was what we needed to know, how is travel changing and evolving as a response to COVID-19, things like trip frequency and journey type changes, and what were people's perceptions and attitudes towards their travel options, and how were these being changed? What did our response as Waka Kotahi or Ministry of Transport or other agencies need to be in terms to lessen that impact, as well as to give everyone sort of back on track. It also allowed us to test assumptions that were being made around, sort of mask use, or whether people were concerned about how catching COVID on buses as compared with taxis and other modes like that. So what I'm going to talk about, because obviously this talk was kind of written back when we had no community transmission, and then we started to have some community transmission. And what I wanted to focus on at the time was really enduring changes, as opposed to sort of that more response mode. So a lot of the results that I'll talk about are the last wave that we did under that sort of no community transmission, which was the 20th to the 24th of May this year, when we hadn't had any community transmission from about 12th March 2021 until that period, and all of New Zealand was under alert level 1. So a lot of our results are published in this format here that we've got here. And what I'll just bring your attention to is really just these two red ovals on either end. So we start off with the one on the left, and that is pre-COVID, what people reported that they did right at the very beginning in the week before we went into any kind of lockdowns. And then right on the right is that 24th of May period. And then going across is just chronological order. So what we can see is that at that period of being in level 1 lockdown, we were getting pretty close to sort of the usual trips that people would generally make. So the top line going across is travelling to work. So we had 50% of people reporting doing that in the last week pre-COVID. And then in that level 1, we had 51% reporting doing that. The next line down is sort of like a peachy colour line, is taking children to and from school. So we had 21% pre-COVID, and then we're up again to 19%. And then the last one is travelling to a place of education, school, university and library, 18% pre-COVID, and then up to 15%. So you can kind of see that over time that these were gradually increasing back towards those pre-COVID levels, hadn't quite got there yet. And so we can dig into, with all this data that we've got, we can dig into all sorts of different things. So this one here is looking at, well, what would be the reasons for reduced passenger transport at that time in that level 1 period. And what we found is that was more because people were traveling less rather than that they were worried about catching COVID-19 from surfaces of people, or I'm concerned that people are not wearing masks on public transport. So basically people could select from a range of things that may be reducing their use of public transport if they were public transport users generally. So the next area that I wanted to talk about was working from home, because this is often kind of the area where people are expecting potentially the biggest changes in terms of environmental sustainability and potential traffic patterns. And so what we've kind of found within this is that if we look back sort of that pre-COVID, around 9% of people report that they were mainly or completely working from home. And obviously that increased in alert level 4 and 3. And then it just started decreasing over time with the subsequent alert level changes. And was still decreasing in that May period, where we were down to 14% of people that were reporting working in from home. So, and then we kind of want to know, well, okay, so what does that 14% break down to? Well, of that 14% of people, 15% would normally be active modes that they would travel to work, 22% public transport, and 62% private vehicles. So you can see that private vehicle number is still quite a high percentage of that total. However, when we start to look at, if we look at that in the opposite direction from the mode direction, so for active modes, within all active modes, commuters are 13% of them are working from home. Within all private vehicle commuters, 9% are working from home, and within all public transport commuters, 15% are working from home. So that working from home has the ability to impact some of those public transport to a greater degree. So we wanted to sort of like dig into that a little bit about that working from home and what is it about those different groups for different modes that might be impacting this. So these statements along the bottom of this graph were statements that were given to people, and they were asked whether they agreed with that statement. So the first one, my preference would be to only work from home as a last resort. What you can see is this green colour here is the people who are active modes. So they agreed less with that statement than the people who were in a private vehicle, which was 50%, agreed more with that statement. And you can see that same pattern in these other questions here of my workplace has become more flexible and open to people working from home, and that's higher amongst those people with using active modes. And my workplace has changed how it operates, so more people can regularly work from home, and that's higher in those active modes as well. So just and some of this we expect would be some of that sort of like CBD, if you like, effect in terms of if you're working in a CBD, you're more likely to be sitting at a computer, which is something that you can do elsewhere, whereas if you're in a rural area, you're more likely to have to actually be physically there. And so we can see that of the 63% of New Zealand's working population who'd like more flexibility, that's strongest in the CBD areas. And of the majority of New Zealanders that report their workplaces have become more flexible, that's strongest in the CBD areas. So that's potentially just what you might expect. We can also break those results down into different age groups. And the part that I'll just point out here is just really these under 30, which is the stark blue colour, what I've got the red ovals on. And you can see that while obviously these under 30-year-olds were effective during the different lockdown levels, when we got back to that level 1 subsequent, when you really had the choice of whether you went into work or not, those the under 30s were right back at the same level as they were pre-alert, whereas it was more the 30 to 49-year-olds and the 50 to 64-year-olds that had that sort of change in the way that whether they were going into work or not. And I think that these kind of things, as we sort of dig down and dig deeper, are things that potentially can be used in the future to go, well, how do we support this in the best way? We also looked at gender, any disability, COVID-19 vulnerability. And the one I've got highlighted on this is the disability numbers. And what we see here is sort of in level 2 and 1, split levels in level 1 and subsequent, they were all around 78, 79 and 80%. So there's actually not that much variation. And we're not really sure whether that speaks to their ability, whether that's where they want to be, is working away from home, or whether that is that they just don't have flexibilities. They have more likely to have jobs that have less flexibility within the places that they work. We also know from other work that we've done within the disability sector with the same tracker that the people with a disability were more reliant on public transport in the lockdown periods as well, that they were still making their trips on public transport to a greater degree, so had less choice and those things. So what does all this really mean? Well, we know that reduced demand for travel is likely to be an outcome potentially of COVID-19. Obviously, you know, with new strains and things like that, we aren't quite there yet. We know that reduced demand is good for transport networks and the climate. However, we note that there's going to be lost fare revenue, and we're always trying to balance those things of the transport system. And we also know that overall costs of providing PT are increasing. So I guess where we're seeing that sort of opportunity is not talking about that winning back of lost customers. Potentially, you know, we're not sort of looking at going back to that system that we had before, but what we want to do is use that as a bit of an opportunity to change that language from patronage recovery to accelerating mode shift. And I think clearly with what Matt was talking about, you know, there's micromobility, there's always other ways of being able to, in Mevo, you know, of being able to travel around. But I think we really need to consider for those who are still travelling to employment, or who are mostly travelling to employment and undertaking other trips, how do we accelerate that mode shift? How do we target those particular groups? What can we do to do that? So that's where I'm going to, I've got sort of one more slide that is just really a wrap up. All of these reports are up on our website at that link. Encourage people to go and have a look at that link. We cover a wide range of different topics, domestic tourism, public transport, modal shiftings, all kinds of things in there. We also have another report up there, which is levering transport disruption to influence change, and that's that sort of that getting that behavioural change as well that I point you to as well. So that's all I really have. Thank you.
Thanks very much, Jo. That's wonderful. I'm going to kick off the questions because I've got one that I think is one of the challenges you're going to be facing. I guess one of the benefits that's always explained to people by advocates is if you shift more people away from their private cars to public transport or active modes, then it frees up road space, right? It frees up road space for those people who do drive. So what a lot of us have seen during these heavy lockdown periods, especially here in Auckland, we've seen a lot of it, is that the roads are freed up and you're not experiencing that congestion. So the driving is even more pleasurable. You don't have the congestion problem. So that's going to be a challenge. I don't know if you thought much about that.
Yeah, I think that's a really big conversation, really. I think in terms of, don't disagree with anything you're saying there, and it is going to be one of the challenges in terms, and don't have a ready solution other than, you know, you've got to make some things, you've got to make some modes harder as well as make some modes easier.
That's right. Yeah.
Yeah.
Cool. Yeah, it's a big challenge for sure. Let's crack into some of the audience questions here. We've got a couple for you and we'll get through them quickly because we are running a little over time. Armin comes in and says, great to see the distributional impact analysis with regards to the survey outcome. Do you have a level of confidence on how reflective this is on wider societal impacts?
We do. Well, I guess we are still looking into these areas. So I don't say that we were there yet. We have done another piece of research just recently that's not published yet. It should be published soon. That's looking, for example, at people with disabilities, their transport experiences, and we have sort of done a dive into that group in terms of sort of a deeper dive into that group in terms of around COVID-19 as well. And so we are still looking into a lot of these things, and I think definitely with the solutions we need to definitely be looking into that wider societal impacts with the solutions.
Cool. And one final question from Martin Nohi. How can modal shift be facilitated in rural areas?
Yeah, and I think the next thing there where you've got encouraging vehicle sharing, mobility service and more working from home. So I read a really neat paper that was done by Otago University that was, I think, I'm just trying to remember exactly where it was, but it was sort of out the back of Gisborne in a rural area, looking at car, looking at ride sharing, kind of more of an organic thing of just looking, at these where and this was sort of like working with an iwi up there and how they were already doing, if they were going into town to go shopping, that they would be asking around who also needs a ride, and so it was more of an organic thing. And I think that a lot of those things, I just feel like some of those solutions are in working with those communities and not so much coming in and sort of saying, hey, this is what you should be doing, but working with those communities to figure out the solutions that work for them.
Mm-hmm. Not an easy one, but we have more tools available to us now, so let's hopefully we can make progress there too. Thank you very, very much, Joe. Really appreciate it, and thanks for answering those questions. We'll keep moving right along, and do feel free to pose more questions to our future speakers. We've got coming up next, we've got Frederick Conker, who's the operations manager for Beam Mobility. He's going to be telling us a little bit how they run things here in New Zealand, and I think with a sustainability overlay on that, how they're achieving some great wins there. Frederick, if you would like to share your screen, or would you like me to run through your slides, because I do have them here.
All right.
There you go.
I'm sharing my screen. Kia ora, ko Frederick Tokoingoa. I am the expansion manager at Beam New Zealand. So today I'm going to take you on a bit of a journey on sustainability and micromobility operations. Cool. So sustainability at Beam. So Beam, for those who don't know us, we're a micromobility shared mobility platform currently operating in Auckland, Wellington and Palmerston North in New Zealand. So our goal is creating, mode shift as well as helping to bring people onto shared micromobility vehicles. How we frame sustainability for us is looking at the sort of the total cost of ownership, the sort of a life cycle assessment model. So essentially that looks at the manufacturing, the shipping, the scooters, the operations, the customer side as well, and then towards the end of life, and throughout that whole process, looking at how we can be the most sustainable, most efficient operator possible. And so from a starting point, a few years ago, we started in New Zealand with sort of the climate neutral side of things. So that was our original certification, looking at how it can be carbon neutral, and then looking at each pillar of Beam. What we've been doing since then is looking through how we can improve on that. And so one of the recent things we've done, along with the COP26 event in combination with the High Consulate here, we've been doing a campaign to drive something new today. So essentially that is helping to show people the benefits of shared e-scooters and e-bikes and how they can jump on board. One other key facet of sustainability is the social and community side. So looking at that social license to operate as well as the general licenses, because in our work with the disability sector, with key residents and business associations, it's really important to us as an operator, making sure we have really good relationships and being able to be listening, to hear feedback, to see how we can learn and grow. As we're a young business and we are growing, but also learning as we go. Looking at the total life of the vehicles, really something like, I think 82 to 85% of total emissions generally come in the materials, the manufacturing and shipping. And not to try and add any rebuttal to Matt's presentation from earlier, which was an excellent piece of research, but noting that those figures are sort of global standards, and we've been finding in New Zealand that we are operating somewhere between 2 to 3 times more efficient than the sort of that global standard. But essentially looking at the materials are, the highest amount of that global warming potential over per kilometre. Those are of course amortized over the vehicle lifetime. So what we've done is actually invested in much stronger and more essentially more robust vehicles, which does have a higher upfront impact, but it will and has been allowing for a much longer lifetime. So we use a fully sustainable battery fleet, which allows us to be a much more efficient operator. What that means is that we can leave the vehicles in place and swap the batteries out when they are needed to be charged. That just saves a huge number of kilometres in vehicles. We're also looking at the maximum amount of recycled materials in our vehicles. So currently I think the standard for this year's vehicles is something around 25% recycled, and that's mostly focused on the aluminium frame and the plastics. But moving towards 50% next year for all the new fleet coming into the country, and that's a real push with the battery side of things, so that using the black mass as well as some of the other key materials that go into our vehicles. I'll explain a little bit more later, but we do all our work in-house, so we don't contract out to third parties. And a key facet for us about having long life vehicles is having really high quality mechanic staff. So we do a huge amount of internal training to help keep our vehicles in tip-top condition and growing and going for the lifetime. You'll note that as well, we have invested in double kickstands for all our fleet now, and they essentially keep the scooter upright a significantly longer period of time. And so that of course feeds back to that social license, but also looking at how we can keep the vehicles in the best condition possible. When the vehicles do come towards the end of life, the key thing for us is either looking at how we can reuse them, and also looking at the supply chain, how they go out of New Zealand. So all our previous vehicles, in terms of where they've been, generally we refurbish and sell them. So there's a fair few ex-beams running around the country. We've got them all around the country, but we also have a global partnership with recycling companies where we can trace the materials all the way through and making sure that we're having sustainable supply chains right to the end of life. Otherwise, from an operations perspective, the key thing for us is having really efficient and sustainable ops. So going back to our in-house ops, so we have all our staff internal, so we don't contract out, we don't use someone's garage with a few sort of makeshift scooter charging apparatuses. So essentially we have our own dedicated warehouse and spaces, so we can build those systems internally. This is about us both investing in the cities we operate, but also looking at how we can grow those skills. The key thing for us is looking at the predictive analytics and the routing efficiency. So how we can make sure our vehicles are in place where there is a need for them, and also looking at disadvantaged communities, how we can provide a service for them to be able to have a good equity and accessibility access across the city. In our internal ops, so looking at electrifying our fleet and using cargo bikes wherever possible. So Beam have a dedicated fleet of cargo bikes in our operations that we use for bringing our batteries around, and those are fully electric. But also the underpinning, the power underneath is looking at how we can purchase traceable power units that we can make sure that we're using fully sustainable power where possible. Cool, how are we going for time? All right. So from a safety perspective, we also have a really good track record on the safety side of things, both from having comprehensive insurance, again, looking at the higher quality vehicles, but also this vehicle safety and the user education. So we provide in-person education training around the country on a regular basis, less so in Auckland recently, but also web-based courses and e-learnings. One thing we're also working on is helping to essentially build and provide real-time feedback for riders, so they'll be able to see, how the rides are going and be able to provide that feedback loop, and that's building into our newer smart IoT system. Going to local benefits. So as an operator, what we try and do is working with local communities as much as possible. So a lot of that's the consultation, the discussions, and also looking at how we can support local businesses. So we have a system which we call Booster. So that's essentially helping local community businesses being able to work with Beam to provide connections to customers or prospective customers. So getting people out and into the cities, improving urban vitality, as well as providing a platform there. This also helps support both from a tourism and again, a mode shift example to help with tourists and people in different cities who are not based there to be able to provide them options. And that is a very brief summary into sustainability and ops at Beam.
Done. Thank you very much. A question from me. What's the pressure from the councils and the governments that you work with to deliver this? And I guess how far ahead of that are you? Are you over delivering, or are you responding to what's required as a basis these days?
So we find that councils and governments across, local governments across the country are really focused on sustainability, but there's also generally looking at more on the sort of safety side of things. But as we go along, the sustainability is becoming more and more important. And for us, we're New Zealand's most sustainable micromobility company, and proud on that. And we are also doing a lot of externally reviewed content on our system, so we can say, hey, to councils, and particularly those smaller regional metros who don't necessarily have the resources to invest on that side of things, how can we share both our technology and our trip data with these councils to say, hey, this is where we're seeing trips, this is where we'd like to look at infrastructure investments and how to improve and grow mode shift across the country.
Mm-hmm. We don't have more questions that have come in from the audience here, so you've obviously done a great job and answered all their questions for them. Thanks very much. Really appreciate it though, Fred. It's good to know a little bit more beyond what you see on the streets, I guess. I'm a regular micromobility user, as you might have picked up from when I was talking to Matt, but it's good to know what's going on behind the scenes. Maybe one more question for you. You guys are a big international company. How do you feel New Zealanders in this space as well in terms of adoption? Is sustainability a big driver for micromobility uptake here, or is it is it just cool new tech, or what do you find the big drivers are?
For sure. So we are part of the Beam Group. So we run the operations in New Zealand locally, but we have the global expertise and the global access to key partnerships and technology, which is really helpful. So we can have a really local focused operation, but also have that larger scale to be able to bring best in class service and transport to New Zealand. People in New Zealand love the sustainability side of things. That's a real draw card, but it is great technology, and it helps that it's also fun, which certainly makes a difference.
Sure. Thanks very much, Fred. Really appreciate your time, and hope everybody enjoyed that. We're going to move on, and I'll share my screen again briefly. We're moving on to Danny Fitzgerald from Fulton Hogan, and Danny is going to be talking about automation in road maintenance. Danny, can you bring up your screen there?
Will do.
And we are a little bit over time. I do appreciate that everyone stuck around, and looking forward to Danny's presentation.
Thank you, Simon. Bear with me here for 1 second.
Yep. I can see that.
Okay. Kia ora, everyone. Thanks for sticking around, like Simon says. I appreciate it's late in the day on a Monday. I'm here to share with you how we're doing or using automation to tackle some of the sustainability challenges here at Fulton Hogan. Before I get into that, for those that are not familiar with who Fulton Hogan are, I thought I'd give you a bit of context about who we are, what we do, and why sustainability is important to us. So Fulton Hogan, we're a contractor. We're initially set up in 1933 down in Dunedin, and in the intervening 90 odd years, we've grown to a team of about 8,000 people who build and maintain infrastructure here in New Zealand, Australia, and the South Pacific. Roughly 1 in every 100 people in New Zealand work for Fulton Hogan. So we're a pretty big company, and the reason I tell you that is when you employ that many people and you do the type of work that we do, sustainability is a very important consideration for us. Our goals in Fulton Hogan are to reduce our emissions by 30% by 2030 and get them down to net carbon zero by 2050. So how are we going to do that? Well, at the moment, we've got a lot of different ways of tackling it. This graphic here shows you some of them. A lot of it is through transitioning our existing fleet of vehicles to hybrids and electric vehicles. Approximately 80% of our emissions are generated from diesel fuel. And as you can see, we produce quite a lot, 30 million litres of diesel every year. So we get through. Today, I'm going to be focusing on how we optimize our plant layouts and work programs specifically. But first, I'll just touch on this one here in the top right-hand corner, remedial work. If you're not familiar with that term, remedial jobs are those where we have to go back out and redo a job because we didn't get it right the first time. For example, if you see a piece of road with 5 potholes in it, we go out there and we fill those potholes, hoping that that road will be okay for the next 6 months or a year, and the road falls to pieces within a month, then we haven't done a good job. We need to go back out there and do a remedial repair, which obviously results in more diesel usage and more emissions. So like I say, just quickly to touch on that, one of the key things for us, and the key success factors when it comes to doing a good job, is making sure our people have access to our best practice guidelines and the information that they need to do a good job. So to facilitate that, we're modernizing the medium that we're communicating and providing to our people to find out that information. And in terms of automation, we're improving how we notify people when that information changes. So right now, we've been on a bit of a digital journey in Fulton Hogan over the last 8 or 10 years, we're moving away from paper and pens to iPads and mobile devices. And we've got over 5,000 iPads and iPhones in our business now. What we're trying to do is catch up with that technology when it comes to our best practices. A lot of our best practices are written in Microsoft Word or PDFs or different documents like that, and we put them on collaboration platforms like SharePoint, which is really good and really easy to get at if you're in the office, but not super easy when you're out in the field. So we're trying to automate that process by creating a new platform similar to Wikipedia, combining a few different technologies that are out there, Wikipedia, Google, and like I say, we're bringing some automatic notifications to it to help our people be informed when information changes, for example, when reviews are due for that information. We send automatic notifications to the content owners, and also small things like if a content owner leaves the business, who owns that information when they leave. If it's in a Word document on an intranet, that stuff can get looked over. We're trying to improve how we do things, and ultimately that will help us do a better job, get it right the first time. I'll jump on to optimizing work programs. This is the main meat of my presentation, I suppose. The work that we do requires a lot of inspecting. For me in particular, I look after technology in our road maintenance business, and to find out what the problems are, we need to get out there, drive around and figure out what the network looks like. Those inspections obviously require a lot of travel and therefore fuel. So that's one issue. They're also infrequent and inconsistent, simply because we're using humans to do it, and that can result in some poor data. Poor data, as it says in the slide there, impacts our decision making. And there's millions and millions of dollars every year spent on maintaining our roads in New Zealand. They're one of our most valuable assets as a country. So if we can improve how we gather that data, that's also going to make us more sustainable, as we won't have to go out there, redo work. We'll choose the right treatments the first time, and so on. It's worth mentioning at this point, I suppose, that the technology I'm going to be talking about here, which is IoT, AI, and machine learning, they have some innate advantages over humans in that they're faster, they're more accurate, they have a lack of bias, but the tech doesn't just help mitigate our emissions problems, it's also very dangerous being out there in live traffic, carrying out inspections. So over in the safety stream at this conference that there's a few people talking about automation as well, and Martin from the N3T team up in Northland representing what they've been doing. So there's a lot of exciting stuff happening in this space. In terms of Internet of Things, we're increasingly, I suppose, trying to replace the need for manual asset inspections by using IoT. This is an ever-evolving space. I think everyone's familiar with the term IoT at this stage. It's coming into all aspects of our lives, but for us in Fulton Hogan, we built a platform where we can put IoT into culverts and sumps, which are drainage assets. And as you can see, here's a screenshot of one of our dashboards where we've got a couple of culvert IoT devices down the bay in Dunedin. And instead of our guys having to go out there and check on those culverts every week or every month, or wherever often our clients ask us to do it, the IoT device will actually send us a message when there's a problem, and we'll go out there and tackle it. Very similar to how you see smart bins popping up in urban areas around New Zealand now, instead of a rubbish truck having to go around emptying your bins every week, and sometimes the rubbish bin will be full and other times it will be empty. Those smart devices send a message to the people that need to empty them when they need emptying. And again, that just reduces the amount of diesel that we need to and fro into the rubbish bins or to the culverts. And obviously it's a better outcome for people in that area as well. Just the same as if a bin is overflowing because there's been an event on a Saturday and the bins get emptied once a week. It's no different to a culvert flooding because of a tidal issue or a lot of rain. So it's a smarter way for us to do things. We're also, it's another slide here of some of the trends that you can see when it comes to those culverts and sumps. So you don't just get real-time information, you also get the history. So you can figure out, if this sump is, this culvert is constantly flooding, then maybe we need to get down there and not just clean it out, but consider installing a bigger sump or a bigger culvert and tackle the root of the problem. So there's lots of data you can capture using the IoT devices. One of the other bits of technology we've put a lot of effort into is installing monitoring on slip sites. So again, a lot of our maintenance contracts around the country, just because of where we are in the world, in New Zealand, there's a lot of movement in the land. And again, that requires a lot of inspections, going back and forwards. And in some parts of the country, it's very expensive operations using helicopters and drones and that type of thing to carry out inspections weekly of dangerous slip areas. So we're installing IoT devices on those sites that monitor the movement of the land. And again, if things start shifting, people get notified. We can go out there and check it out. That's what we're doing in IoT. One of the big things that I was going to talk about in this presentation is artificial intelligence and machine learning. AI and machine learning are relatively new terms, I suppose, in the parlance of technology, but they've been around for a long time. This picture here is a picture of the Stanford cart, which was the first vehicle that anybody really deemed to be autonomous. And it was first built in 1961. So it could navigate around obstacles using cameras, and an early version of artificial intelligence by the early 70s. The only problem was it needed 10 or 50 minutes to move 1 meter. So obviously computing power has come on a long way since then. It just goes to show how quickly this technology is advancing. For us in Fulton Hogan, we decided that we wanted to try and automate our road inspections. So instead of sending a person out in a car, like I mentioned earlier on, we could send them out in a car, but less often. And we could use machine learning and artificial intelligence to tackle those issues that we currently have with inspections. So to start our journey, we looked at how are we going to capture the data. And initially we looked at some high-end LiDAR units, which have some great uses in engineering. That's one there on the left. But they're very expensive, they're very big. They can cost about $500,000. And like I say, they have a lot of good uses in engineering, but for us, we only needed imagery. And so after trialing a few different cameras, we landed on a GoPro camera. The GoPros are smaller, and therefore they're easier to cart around. They capture great video quality. They're weatherproof, bump-proof. They're about 1,000 times less expensive than a LiDAR unit. So it made sense for us. That's how they compare in terms of size. Once we decided what we're going to capture the information using, we needed to figure out how we're going to create some artificial intelligence. And we did this, and we're continuing to do it by using some machine learning technology. Machine learning and artificial intelligence, what does it all mean? I like to compare it to training a baby. Think about how we learn. Our eyes are constantly capturing images. Our brains are constantly analyzing those images, and we learn. I've got some young kids at home, and it's pretty amazing to watch them learn and how quickly they do it. Machines are the same, but the benefit of machines are they never stop learning. They never taper off. The older we get as human beings, I often say that it's pretty amazing that our kids learn how to speak whatever language they're going to be fluent in within 3 or 4 years of being born. I have a 5-year-old at home, and he speaks English just as well as I do, if not better. He's speaking Maori. I can't speak any Maori. But if you asked me to learn a new language today, I wouldn't be able to learn English in 4 years. There's no way. To the level that he can speak it. And machines are the same. Machines keep that rate of learning up constantly. So in this slide here, we've all probably seen something like this when you're logging into your email in your browser. These catchphrases where you're asked to identify traffic lights and a picture in this scenario. And what Google are using here is they're taking imagery and they're asking you to identify what's a street light in it, so they can train their own self-driving vehicles or self-driving cars, because all those vehicles need to know what is a traffic light. So how do you teach it? You show it a picture of a traffic light, and you show it lots and lots of pictures of traffic lights, just like you show your kid lots of pictures of a traffic light, and they'll learn what it is. To my example before about how machines keep on learning, Google tested some of these machine learning algorithms on some of the really distorted catchphrases. So back in the day before we had pictures, we used to get given words, if you remember that. And they put some really, really distorted text in front of people, and humans got the test right about 33% of the time. But the machines came along and got 99.8%. So it just goes to show how good they can really get. The product we developed here, I'll just pause this video and I'll take you through it a bit slowly. So we've developed for ourselves a product where we can go in, upload the video that we capture out of those GoPros, and it's a platform that we can use to train our model. And the model's learning all the time, but just like training a human being, you need to show them pictures of something for them to learn. So we created a web-based platform where you can take the video off the GoPro, you log in here, you select your contract, your inspector, some other information, and you can put your video onto the platform. The platform will analyze the video and give you some results. Like for example, here we can see we've got 1,234 defects on this network. You can review them using this platform. See how many defects you've got, what the severities are, and so on. There's also a map where you can look at that kind of thing. But the main purpose of this platform for us was to help train the machine to make sure that it was getting the right data. Like I said before, machines don't have any bias. So our inspectors, with experience, they get out there and they don't pick up every single problem with the road, because much like when you drive a car off of a forecourt, a brand new car, as soon as you drive it off the forecourt, you know, it starts deteriorating. And roads are the same. There's very few perfect roads out there. So when you send a machine out there to pick up all the problems, it's going to give you a lot of data. So you need to be able to filter that data down. So in here, we can review the data, pick up any issues that we think the machine hasn't got quite right. The more images, the better. Just like when you're training a human, the more pictures you show them, the better they get. For a good machine learning algorithm, generally you need probably in the region of 10,000 images. Gets real tricky, and it's taken us quite a while to do it. This is what the machine looks at when you're driving along the road. It's constantly spotting these defects on the road, capturing them. Where it gets really tricky with this type of capture is, you know, if I give you a quick example of if there's a piece of rubbish on a road and the machine doesn't know what the piece of rubbish is, it can easily just think it's a pothole. So ultimately what the machine is looking for is just differences in the pixels in the image. It's just recognizing a series of pixels or a pattern. And it's okay, that looks like cracking, so I want to call that cracking. Or maybe a circle of black might be a pothole. But if someone throws a bag on the road, they can also identify that as, well, that looks like my sequence of dots that I associate with a pothole, and it becomes difficult to identify and get good data out of it. So that's why we built the platform, is ultimately to keep training our model and improve it as time goes along. I'm going to show you a couple of uses for this data once you've captured it. So this here is a Power BI dashboard that one of my colleagues knocked together. They pulled in the data out of our RE system, and you can see an example when I click play here. They start to look at what's known as fatigue cracking, which is just lots of cracking on the road. When water gets into the road, it's not good news, and water gets in through many different ways, but cracking is one of them. And you'll see here, there's a good example of cracking. You might not be able to see very well. There's a big shadow in that picture. The shadows are another big challenge for machine learning, dealing with shadows. But here in a second, you'll see it goes and picks a different type of defect. Well, different defect in a different location, and it's also a cracking defect. But when you look at this, it's obviously paving stones and not cracking. And that's the kind of thing that we're always trying to teach our model with. You'd be amazed how many different patterns there are. Let's move this video on here a little bit. So again, lots of different, in this case, looking at deterioration and prioritized by filtered by the different priorities and so on. I'll jump past this video just to be conscious of time. So this is the last video I'll show you here. This is another example of how we use this data. In this particular example, it's focusing on our challenge at the beginning around optimizing work programs. So we build up a program of work, generally monthly, but also longer term programs over the course of the year. And obviously the programs are dictated by how much money our clients have to spend, what the needs of the network are, and so on. And like I mentioned before, RE and the machine learning systems gather quite a lot of data. So you need to be able to filter it down. So this dashboard here, which is created by one of my colleagues, allows us to, in this particular example, look at how many potholes they can get done for their budget. So in this case, they might have $9,000 of budget, and they're looking at the priority of the defects. They're deciding now that they want to fix all the potholes between priority 3 and priority 6. That's going to cost them $8,000 to get it done. So they can play around with these sliders here, play around with the data, and decide objectively what issues to tackle on their network, and have confidence in the data because it was all collected without any bias, like I mentioned earlier on. So it's helping out our clients get the most bang for our buck, and ultimately our communities through having better roads and better assets. That's my presentation for today. Thanks for your attention. Yep.
That was great. Thanks very much, Danny. Fascinating to see how far you guys have got with your systems there. Yeah, I mean, obviously the benefits are almost are pretty obvious, but there's a lot of work that goes in behind the scenes, I'm sure, to make it happen, and still a long way to go as well, perhaps, in terms of teaching machines to identify from pictures. Now, I've got a couple of questions here from the audience. If you can address some of these. First, we've got one from Doug Wilson. I think you may have gone through this just after he asked it, but maybe you'd like to address it a little bit more in detail. Is Fulton Hogan using or considering using smart infrastructure sensors for asset management or vehicle monitoring to optimize construction and maintenance treatments? Activities to enable
sure.
Yep.
Yeah, for sure. Like you mentioned, I touched on a couple of those with the culverts on the slides and the land movement stuff, slip monitoring that we do. There's lots of stuff going on in that space. You know, another quite a common, I suppose not a common term, but a piece of technology that's starting to become more widely spoken about is digital twins. In our industry, and to create a digital twin, you need to supply it with data, and the more up-to-date data you can give it, the better. So, for example, if you want your digital twin to tell you what parts of your network are going to be at the most risk of a flood, then you need to know what the current profile of that network is in real time, and where that flooding is happening. So, more and more sensors allow us to do that, and I feel like that's the way our game is going. You know, in 20-25 years time, there'll be a lot less people driving around networks looking for problems. There'll be a lot more IoT out there. We'll have self-driving cars out there, satellite imagery to look at, all that type of thing. It's a pretty exciting time in terms of technology.
Cool. A very quick question from Martin, who you mentioned in your presentation as well. He's asking what AI model you're using for your real-time inferencing.
Yeah, good question, Martin. I don't know the answer, and I'm not deep enough in the weeds of the technical side of it to understand that, but I'll go and find out for you. I'll drop you an email.
Cool. And finally, a little question from Armin as well, talking about the information on low energy asphalt from one of your earlier slides and the CO2 emissions reductions. This is something that ITS New Zealand's been thinking about digging into as well with a future event. Have you got any more?
Yeah, that's I don't want to, again, I'm sorry, I don't have any more information on it myself. It wasn't one of the things I dug into for this presentation, but again, I know the folks involved. I can put you in touch with them. I didn't catch the name of that person, but if you share my email with them, drop me an email and I'll put you in touch.
I will do indeed. Yep. Thanks very much, Danny. I really appreciate it. Now I'll wrap up there. Actually, there were a few unanswered questions that happened during the event. Not surprising. Number 7 speakers to get through in a limited time, and so we'll be passing on those questions to our speakers, and they can get back to you in time. Otherwise, in their presentations, you'll obviously find their email addresses there. So Danny had his email address in there as well, and we'll be providing a recording of this presentation, of these presentations, plural, up onto our YouTube channel in the coming days as well, and we'll be giving the audience an opportunity to vote on their favourite presenters as well. So looking forward to getting your feedback there again, but there's already some feedback coming through here in the Q&As and in the chat as well. Thanking all of our presenters for the time and effort they've gone to inform us all on the progress they're making and what they're doing to achieve better sustainability and efficiencies and outcomes across the board. Really appreciate it. Thanks again, Danny, and to all of our speakers. And if you've got any questions about this more broadly or ITS New Zealand, don't hesitate to get in touch with me. Thank you very much.
Hey, Simon, I'm sure I speak for everyone here to say thanks for sticking with it and reorganizing the conference. It's been really good to see the presentations eventually. So I appreciate it, and I'm sure everyone else does. So thank you.
Thank you, Danny. Yes, we look forward to some in-person events in future, and just more events in general would be good too, because we've lots to catch up on. It's moving so quickly. Thank you.
Simon.